Okay, to simplify a rational expression, you want to break up the expressions into factors. So for example, if you had 36 over 27, we could break it up, the numerator as 4 times 9, and the bottom one as 3 times 9, and they both have 9 as a common factor. So if we go ahead and reduce that, you get 4/3. So when it comes to reducing rational expressions, there's a couple of things we want to do. We want to use the idea of factoring even for polynomials that look like this. So if you have an expression for x to the third minus 16x to the fifth, what we can do is figure out what both of them have in common in terms of a factor. So looking at the numbers, we know that 4, they both have a factor of 4. They also have a factor of x to the third. So if we go ahead and divide those out, we have 1 minus 4x squared left over. And so you can see that these two expressions are actually equivalent. Another factoring problem would be something that follows the differences of two squared numbers. So if the first one and the second one is squared, and if there's a minus sign in the middle, we can break it up as a plus b times a minus b. So an example would be something like this, x squared minus 49. We want to figure out what your so-called a is, and so in this case, if we square root it, we get x. If we square root the 49, we get 7. And so it follows a pattern, so we can write it as x plus 7 times x minus 7. And if you check it by foiling it back or doing distributed property, you notice that it actually does equal to x squared minus 49. So this has to be the factoring for this particular problem. So another one that you learned is if the polynomial patterns where the first one is cubed and the second one is cubed, but they could either have a plus or minus sign. So you want to make sure that you remember these equations as follows. So again, if we have something like x to the third plus 8, I know that the cubic number here, or the number that's being cubed here, is actually x. If we look at the second part, we know that this one is 2. So just fitting it into the formula, you can actually factor it in this fashion. And it's actually the same if it's x to the 3 minus 8. It's just that the signs in between them is basically the only difference. So if you have a minus sign, the first one has a minus and the second one's a plus. If the first one's a plus, then the next one's a plus and the second one's a minus. So if you see a trinomial, most likely you can break it up into two binomials. So for example, for this one, the first thing I notice that it's 3 terms, so it's considered to be a trinomial. And I probably would just put in the parentheses and start figuring out what numbers would go into the first slot. And remember, those numbers come from the first term here. So I'm going to write down 3x. And then for the second one, again, you have to think about the choices that you have for the factors of 1. You could either use 1 times 1 or negative 1 times negative 1. In this case, because the middle here is positive, I'm going to go ahead and put in plus 1 and plus 1. And remember, you always want to check to see if the middle term matches by doing the OI part of FOIL. And you can see here it does match, so this would be the answer to this problem. The other factoring that you might be familiar with is splitting the middle term. So if you have 4 terms, try splitting the middle and see if you could factor the first 2 terms and the last 2 terms and see if those 2 terms have anything in common. So for this particular example, I know that the first part has x squared in common. And for the second one, I am trying to get the binomial here to match with this binomial here that will be left over. So in this case, negative 5 actually works. And then again, both of these now have x minus 4 in common, and whatever's left over, so in this case, this part here is left over, and this part is left over, so this becomes x squared minus 5. So for this one, again, here are some examples. Again, you want to look for the common factor. So for this one, I know that the top and the bottom has 5 in common, so if I go ahead and reduce it, I do get 2x over 5 for this first one. For the second one, again, you want to look at the numbers here and then the variables. For the numbers, we have 3 in common, so we can reduce the top one by 3, which leaves with 9. The bottom one leaves with 10. B squared and b to the fifth had b squares in common, so we can go ahead and cross that out with just 2 b's, which tells you that the bottom one is left over with b to the third. And so final answer is 9 over 10b to the third. For number 3, we're looking for the greatest common factor. So in this case, the top one actually has 3 in common. So if we go ahead and factor out the 3, notice that now we can go ahead and cross out c plus 11. Remember, you cannot cross out a binomial. If you do cross out one part of the binomial, then everything also must be identical so that you can reduce it. So in this case, they are. So final answer for this problem is 3. Again, for this one, although we would love to cross out these 8s and maybe the d's, we cannot. Again, this binomial is stuck together as one binomial, and the bottom is one binomial. Again, if you'd like to cross any of it out, all of it has to be crossed out together. So in this case, it is already simplified. For this one, I'm going to find a common factor for the bottom one. So the top one is already factored out as much as possible. For the bottom, I notice that 8w is a common factor between the two terms. And then from here, I'm going to go ahead and reduce the 48 with the 8 and the w's. So final answer for this one is negative 6 all over 2w minus 5. So for this problem, we're going to go ahead and factor out a greatest common factor from the top side. So we're looking for the greatest monomial. And for the bottom, this is a trinomial, so I'm probably going to break it up into two binomials. For the top one, they both have 7x in common, so I will factor that out. And for the bottom, again, writing two binomials here, 2x plus 3 times x minus 1 would work. And you can see here, they both have 2x plus 3 in common, so I'll reduce that. And the final answer is 7x over x minus 1. In this case, I notice the top and the bottom are trinomials. So again, I'm going to go ahead and factor them as two binomials. And this one actually does factor nicely. So we get x plus 8 times x plus 8 over x minus 8, x plus 8 times x minus 1. And again, the x plus 8 crosses out. So final answer for this one is x plus 8 over x minus 1. So here's another example that actually uses a cubic rule. So if you notice, the top one actually does pattern two cubic numbers being added. So I would actually use the formula that was given to you earlier. And for the bottom, again, I notice it's a trinomial, so I'm going to actually try to split it up as two binomials. So if I do follow the formulas, I do get this particular setup. And again, I notice that x plus 2 and x plus 2 is a common factor to the top and the bottom here. So I'll go ahead and cross those out. And so final answer will be x squared minus 2x plus 4 over x plus 2. And again, remember not to cross out any parts. This is all considered one number on the top when you're adding or subtracting them. Here's an example of splitting the middle term. If you notice, the top here has 4 terms. So the technique I'm going to try here is to split the middle term. This is the same exact example I actually did in the front of the video. So I'm going to go ahead and write out the answers here, and you can go back and look to see how that was done. And then if we notice here, again, remember the bottom is considered a one number here because it is a binomial. And in this case, x squared minus 5 is a factor to the top as well. So if I go ahead and reduce that, you get x minus 4 as your final answer. So remember, in order to work with these problems, just like regular fractions with numbers, if you have a polynomial and you're trying to reduce a fraction with polynomials, it's the same idea where you want to factor things out.